Hello and welcome back to Engineers Olympiad, where learning meets success. We're continuing with the numericals of the first chapter, Introduction and Basic Concepts of Surveying. So let's begin. Question is, a plan represents an area of 93750 square meters and measures 6 centimeters cross 6.25 centimeters. Find the scale of the plot, right? So the plan represents an area, that is area of survey is 93750 square meters. But on plan, on map, it represents an area of 6 centimeter cross 6.25 centimeter. We have to find the scale of the plot. What is the actual area on the plan? Actual area on the plan is 6 cross 6.25, right? Which is equivalent to 37.5 centimeters square. This is the area on the plan. What is actual area on the ground? Area on the ground is 93750 meter square, right? Which can be written as 93750 into 10 raised power 4 centimeter square, right? Now what we have to do? We have to find the scale of this plot. Scale is 93750 into 10 raised power 4 divided by 37.5. But since we are dealing with the area, square root of it, and it comes equivalent to 5000, right? So the scale is 1 centimeter is equal to 5000 centimeters. That means every 1 centimeter on this plan represents 5000 centimeters on the ground. So it can also be written as 1 centimeter is equivalent to 50 meters. So this is our engineer scale of the plan. And if we have to represent it as representative fraction is 1 by 5000, right? So this was the question and we solved it, and the scale of the plan was found equivalent to 1 centimeter is equal to 50 meters, right? Let's move on and do the next one. Next question is a 1.2 kilometer long road is indicated in a map by a length of 30 centimeters. By a length of 30 centimeters. Find the scale of the plot. We have to find the scale of the plot, right? So let's solve it. What is the question? Question is, a 1.2 kilometer long road is indicated in a map by a length of 30 centimeters. We have to find the scale of the plot. So what is the scale given? That is 30 centimeter, right? A 1.2 kilometer long road is represented by 30 centimeters on the plan, right? That means 30 centimeters represents 1.2 kilometer length on the ground. That means 1 centimeter represents right? So 1 centimeter represents how much? 0.04 kilometers, right? Or I can write it like this, 1 centimeter is equal to right? So 1 centimeter will be equivalent to 4000 centimeters on the ground, or the scale is 1 centimeter is equal to 40 meters. This is our engineer scale, and the representative fraction is 1 by 4000. Right? So this was the question, that 1.2 kilometer long road is indicated on a map by a length of 30 centimeters, and we have to find the scale, and we found the scale equivalent to 1 centimeter is equal to 40 meters, and our representative fraction is 1 by 4000. Let's solve another question. Next question is, okay, a rectangular plot of land a rectangular plot of land of 0.45 hectares is represented on a map by a similar rectangle of area 5 centimeters square. Calculate the representative fraction of the scale. Calculate the representative fraction of the scale. Right? The question is, a rectangular plot of land 0.45 hectares is represented on a map by a similar rectangle of area 5 centimeters square. We have to calculate the representative fraction of the scale. Right? Scale is given that 5 centimeter square represents how much? 0.45 hectares on the ground. Or I can write 5 centimeters square. As we know, 1 hectare is equal to 10 raised power 4 meters square. Right? So 5 centimeters square is equal to 0.45 into 10 raised power 4 meters square. Right? Or I may write it 1 centimeter square is equal to right, which comes equivalent to, by calculation, it is 0.09 into 10 raised power 4 meter square. If I want to convert it into centimeters, I will write it down like this. 1 centimeter square is 0.09 into 10 raised power 4 into 10 raised power 4 centimeters square. Right? So my 1 centimeter square is equivalent to 900 into 10 raised power 4 centimeter square. Then my 1 centimeter, square root on both the sides, my 1 centimeter will come equivalent to 3000 centimeters, right? By square rooting, by putting square root on both the sides, my 1 centimeter will come equivalent to 3000 centimeters on the ground. That means, what is my scale? 1 centimeter represents 30 meters. But the question is asking to find the representative fraction, which is equal to 1 by 3000. Okay? So the representative fraction is 1 by 3000. So this was this was the next question. Let's try to solve more questions. I may rub it first. Okay. Let's try to solve the question. The question is, a plant represents an area of plant represents an area of 39672 meters square and measures 4.75 centimeter cross 5.22 centimeters. Find the scale of the plot. Find the scale of the plot. Right? Let's try to solve this question. The question is, a plant represents an area of 39672 meters square and measures 4.75 centimeter cross 5.22 centimeters on the plan. We have to find the scale of the plot. What is area on plan? .75 centimeter cross 5.22 centimeters, right? So my area on the plan is 24.79 centimeters square. Right? What is the area on the ground? Area on ground is 39672 meters square, right? So I may say that 24.79 centimeters square on map represents 39672 meters square on the ground. That means 1 centimeter square is equivalent to, by calculations, 1600.322 meters square, right? Every 1 centimeter square on the plan represents 1600.322 meter square. If I may have to represent it in centimeter square, it will come equal to 10 raised power 4 centimeter square, right? So 1 centimeter square, will ignore this fractional part, right, at 1600 into 10 raised power 4 centimeter square. By putting square root on the both sides, my 1 centimeter will be equivalent to 4000 centimeters. That means my scale is 1 centimeter is equal to 40 meters and my representative fraction is 1 by 4000. Right? So this was the question, and we found the scale of the plot, which came equivalent to 1 centimeter is equal to 40 meters. Every 1 centimeter on the plan represents 40 meters on the ground, and our representative fraction came equivalent to 1 by 4,000. Let's try to solve another question. So the next question is, a line of 5 meters on the original map is shrunk to 4.6 meters. Calculate the shrunk scale if the original scale of the map was how much? 1 centimeter is equal to 80 meters. 1 centimeter is equal to 80 meters. So the question is, the line of 5 meter on the original map is shrunk to 4.6 meters. We have to calculate the shrunk scale if the original scale of the map was 1 centimeter is equal to 80 meters. Please recall the discussions as held in the theory part of the same chapter, wherein I told you that these maps shrink due to variation in atmospheric temperature and humidity, right? So let's find the shrinkage ratio or shrinkage factor first. Shrinkage ratio or shrinkage factor is equal to shrunk length divided by original length, right? So what is my SF, shrinkage factor or shrinkage ratio? What is my shrunk length? 4.6 meters. What is my original length? 5 meters. So my shrinkage ratio or shrinkage factor, which is a dimensionless quantity and always less than unity, which must be noted by the students, it comes equivalent to 0.92, right? Now, what does the question demand? Calculate the shrunk scale. If the original scale of the map was, original scale, how much? 1 centimeter is equal to 80 meters. That means 1 centimeter is equal to 8,000 centimeters. That means representative fraction, the original representative fraction will be 1 by 8,000. Right? 1 by 8,000 is my original representative fraction. So I have to find the shrunk scale. I know that shrunk RF is equal to original RF multiplied by shrinkage factor or shrinkage ratio. What is my original RF? What is my shrinkage factor? Please do not confuse yourself here. Let me write it again. Which will come equivalent to 1 by 8695. So my shrunk RF is 1 by 8695, which means 1 centimeter represents 8695 centimeters, or 1 centimeter is equal to 86.95 0.95 meters. So this is my shrunk scale, right? So we found the shrunk scale, and which came equivalent to 1 centimeter is equal to 86.95 meters, right? Let's try to solve the question. Next question is a plan of an area drawn with the original scale of 1 centimeter is equal to 10 meters. Has shrunk such that a line originally 15 centimeters long on the plan now measures 14.5 centimeter. 14.5 centimeter. The shrunk scale is given by by 1 centimeter is equivalent to So the question is, a plan of an area drawn with the original scale of 1 centimeter is equal to 10 meters had shrunk such that a line originally 15 centimeters long on the plan now measures 14.5 centimeters. The shrunk scale is given by 1 centimeter is equal to, right? So what is the original scale? 1 centimeter is equal to 10 meters, right? That means 1 centimeter is equal to 1000 centimeters. RF is 1 by 1000. This is my engineer scale. This is my representative fraction. Let's try to find shrinkage ratio or shrinkage factor. Shrunk length by original length. What is my shrunk length? 14.5 centimeters. What is my original length? 15 centimeters. It will come equivalent to 0.96. You must note it's a dimensionless quantity and always less than unity. Now, I have to find the shrunk scale. My shrunk RF is equal to original RF multiplied by the shrinkage factor. My original RF is, my shrinkage factor is, so my shrunk RF is equal to 1 by 1042. That means 1 centimeter represents 1042 centimeters on the ground. That means 1 centimeter is equal to 10.42 meters. This is my shrunk scale, right? So I found the shrunk scale, which came equivalent to 1 centimeter is equal to 10.42 meters. Okay, let's try to solve another question. Let me rub it first. Okay, moving on, let's try to solve another question. So the question is the plan of a survey. The plan of the survey. The plan of the survey plotted to a scale of plotted to a scale of 1 centimeter to 10 meter, 1 centimeter to 10 meter is reduced in such a way, is reduced in such a way is reduced in such a way that a line originally 10 centimeters that a line originally 10 centimeters now measures 9 centimeters. Now measures how much? Only 9 centimeters. The area of the reduced plan is measured as the area of the reduced plan is measured as 81 centimeter square. The actual area of the survey is the actual area of the survey is, right? So let's find the solution to this question. The question is the plan of a survey plotted to a scale of 1 centimeter to 10 meter is reduced in such a way that a line originally 10 centimeter now measures how much? Only 9 centimeter. The area of the reduced plan is measured as 81 centimeter square. The actual area of the survey is, what is my original scale? My original scale is 1 centimeter is equal to 10 meters. That means 1 centimeter is equal to 1000 centimeters. My original RF is 1 by 1000, right? What is my shrinkage factor or the shrinkage ratio? Shrunk length by original length. My shrunk length is 9 centimeters. My original length is 10 centimeters. 0.90 is my shrinkage factor, right? Now, the area of the reduced plan is measured at 81 centimeter square. Now, I have to find the correct area first, right? And the correct area is equal to measured area divided by the square of the shrinkage factor, right? My measured area is how much? 81 centimeter square. My shrinkage factor is 0.90. So my correct area on the plan will be equal to 100 centimeter square. How much? 100 centimeter square. But the question doesn't ask this. The question asks us to find the actual area of the survey. That means we have to find the actual area on the ground, right? So that will be equal to how much? What is my scale? 1 centimeter represents 10 meters, right? Every 1 centimeter on the plan measures how much? 10 meters on the ground. So what will be my actual area of survey? Let me rub it. First, my actual area of survey will be how much? The correct area on the plan, how much was that? 100 centimeters square multiplied by the scale. What is my scale? Every 1 centimeter presents 10 meters on the ground. That means 10. But since we are dealing with the areas, the square of it, and it will come equivalent to 10,000 meters square. 10,000 meters square. So this is my actual area of survey. Right? My actual area of survey is 10,000 meter square. Let's solve another question. Let me rub it first. Let's take another question. Next question is, okay, a rectangular area of how much? 12 kilometers square. A rectangular area of 12 kilometers square is represented by 1.5 centimeter cross 0.5 centimeter. Rectangle on a map. Right? Rectangle on a map. The scale of the map is the scale of the map is, right? So the question is, a rectangular area of 12 kilometers square is represented by 1.5 centimeter cross 0.5 centimeter rectangle on a map. The scale of the map is, we have to find the scale of the map. Okay, so what is the area on the plan? Area on the map or the plan is represented by 1.5 centimeter cross 0.5 centimeter, right? That is equivalent to how much? 0.75 centimeter square. And what is the area on the ground? That is 12 kilometers square. That means 0.5 centimeter square on the map represents 12 kilometers square on the ground, right? So 1 kilometer square will represent how much? 12 kilometers square, right? 1 kilometer square is equal to how much? Right? That means 1 kilometer is equal to, if we'll take square root on the both sides, right? That means every 0.25 centimeters on the map represents 1 kilometer on the ground, or I may say 1 centimeter represents how many kilometers? 4 kilometers. This is my scale, and if I have to represent it as a representative fraction, it will be equivalent to 1 by right? So this was the question, that a rectangular area of 12 kilometers square is represented by this much rectangle on a map, and we had to find the scale. My area on the map was this, and so my scale came equivalent to 1 centimeter is equal to 4 kilometers, or the representative fraction came equivalent to 1 by 4 into 10 raised power 5, right? Let's solve another question. So the question is, a survey is conducted with a view to prepare the map of an area to a scale of 1:1000, to a scale of 1:1000. If a scale with least count of least count of 0.1 mm is used for plotting, what would be the accuracy in the length measurement in the field? What would be the accuracy of the length measurement in the field? Of the length measurement in the field, right? So the question is, survey is conducted with a view to prepare the map of an area to a scale of 1:1000. If a scale with the least count of 0.1 mm is used for plotting, what would be the accuracy of the length measurement in the field? Right? What is my scale? It is 1:1000, right? That means every 1 unit represents 1000 units on the ground, and I have used a scale which has a least count of 0.1 mm. So what would be the accuracy of the length measurement in the field? The accuracy of the length measurement in the field will be accuracy of length measured as in the field will be equal to least count 0.1 mm multiplied with scale, that is 1000, which will come equivalent to 0.1 10 centimeters, or I may write it as 0.1 meter. That means the accuracy of length measurement in the field will be equivalent to 0.1 meter, right? So with this we conclude today's video lecture. I hope it was informative, and thank you for watching.